This video is an introduction to the chapter Ratio and Proportion. Let's start with an example. Imagine that you're cooking pav bhaji for your family, and let's assume that you have 4 members in your family. Now, there are many recipes which you can follow. You browse online and you come across this recipe, and here you see a list of ingredients along with the quantity. The serving size is 4. So you can follow this recipe if you have 4 members in your family very easily. And you would follow these quantities. For example, you can take 2 potatoes for this recipe and 1 onion, like that. But what if you wanted to replicate the same recipe for a large gathering, and suppose you wanted to serve 15 people, but you still wanted to follow the same recipe to get the same taste, right? How can you modify the same recipe? You can increase the quantity of the ingredients by the ratio 4:15. Since the previous recipe was showing quantities for 4 servings and you want 15 servings, you can increase in that ratio. So the recipe gets modified accordingly. So this is for 15 servings, and you notice that the amount for each ingredient has increased in that same ratio. So earlier, when the serving size was 4, we had 2 potatoes. Here the serving size is 15, we have 7.5 potatoes. So you see that 2 and 7.5 is the same ratio as 4 and 15. 4:15, 2:7.5. And even the ratio of 2 different ingredients has remained the same. So earlier, when the recipe had 2 potatoes and 1 onion, this recipe has 7.5 potatoes and 3.75 onion. So even that ratio of potato to onion remains the same. So you see that the proportion is important here if we want to maintain the same taste and have the same recipe, but for different serving sizes. Now, there are other recipes where this has to be followed very accurately, especially when it comes to baking. Now, let us learn about proportions in more detail. Any 4 non-zero quantities A, B, C and D are said to be in proportion or are proportional if A is to B is equal to C is to D. So we can take the previous example. We had 4:15, that was equal to 2:7.5. So I can say that these quantities 4, 15, 2 and 7.5 are in proportion, or they are proportional. Okay, and I can also write the same as A is to B as C is to D. So 4:15 as 2:7.5. That is how it is read. And let us look at some more details. It says if we have a proportion like this A, B, C, D, then A, B, C, D are the terms of the proportion, where A is the first term, B is the second term, like that. So in this proportion, 4 is the first term, 15 is the second term, 2 is the third term and 7.5 is the fourth term. And A and D are called extremes. So 4 and 7.5 will be called extremes, whereas B and C are called means. So 15 and 2 would be means. And another important relation among extremes and means is that the product of the extremes will be equal to product of the means. So in this proportion I can say that product of the extremes is 4 into 7.5. That should be equal to 15 into 2. So if I calculate that, both the sides will be 30. Then the next thing is that in this kind of a proportion, the fourth term is called the fourth proportional. So here 7.5 would be my fourth proportional. And here quantities A and B must be of the same kind with same units, whereas C and D may separately be of the same kind and say same units. So 4 and 15 should have been the same kind and with same units. And 2 and 7.5, they can be different from the previous ratio in terms of what kind of numbers they represent or what units they are expressed in. But among these two numbers, 2 and 7.5, they have to be the same kind and the same units. This example is given like 5 kg is to 15 kg. This ratio can be equal to another ratio of 75 rupees is to 225 rupees. Okay. Then the next topic is continued proportion. This is a proportion where you have three non-zero quantities of the same kind and in the same unit. And if the ratio of the first to the second is the same as the ratio of the second to the third. For example, we can have a ratio like 2 is to 4 and 4 is to 8. And this will be in proportion because 2 is to 4 is the same ratio as 4 is to 8. And we see that there are three unique numbers. We have 2, 4 and 8. Now 4 is in the mean positions. 2 and 8 are my extremes, but 4 is the mean position. So here I say that the mean proportional is 4. We don't have a fourth proportional because we only have three unique numbers, 2, 4 and 8. So 8 will be my third proportional. And the number 4 is actually my mean proportional. Here, both the means are the same number. It's just 4. So 4 is the mean proportional. Alright. Now if you look at example 12, find the fourth proportional to 3, 6 and 4.5. So when they're asking to find the fourth proportional, it is actually not a continued proportion, it's a regular proportion with 4 quantities, and the first three are 3, 6 and 4.5. So you can assume the fourth proportional to be x. So the proportion would look like 3 is to 6 as 4 is to x. So we can write like this, and we can use the property that the product of the extremes 3 into x will be equal to product of the means 6 into 4.5. So solving for x we get 9. Then in the next question we have to find the mean proportional between 6.25 and 0.16. Now whenever mean proportional is mentioned, you would know that this is a case of continued proportion. So if we assume the mean proportional to be x, then the numbers 6.25, x and 0.16 are in continued proportion. So we can write 6.25 is to x equal to x is to 0.16. And again, if I apply the property that the product of the extremes is equal to product of the means, then mean is simply x. So x into x will be equal to 6.25 into 0.16, which gives me x equal to 1. And in part 3, we have to find the third proportional to 1.2 and 1.8. So since the last is the third proportional, that also tells us that we only have three numbers and it is a case of continued proportion. So we have the numbers 1.2, 1.8 and the third proportional, let it be x. So these three numbers are in continued proportion. So I can say that 1.2 is to 1.8 is equal to 1.8 is to x. So again, using the property that product of the extremes is equal to product of means, I can find the value of x and that would come out to be 2.7. Alright. Now you can go through the solved examples 13 to 22, which are given in pages 89 to 94. This is your first task. After you go through the solved examples, you can try to solve these questions from exercise 7b. Question number 1 part 1, 2 part 2, 3 part 1, 4, 6, 7 part 1, 8 and 10. In the next video, we will discuss the solutions to these questions.